some of the discussion that we are going to discuss here will be related to immune tolerance. So what is immune tolerance? Is just in basic, yeah. So immune tolerance is a condition where our immune system knows, there are cells that is going to attack us. Yeah, there are B cells, T cells, antibodies going to attack us. So we have to, our system, Allah Subhanahu wa Taala created, very, very nicely, when all these antibodies, or all these what I call T cells and B cells that's supposed to attack us, Allah Subhanahu wa Taala eliminated it immediately, where we have this what we call a central tolerance and peripheral tolerance. I'm not going to explain to you in details on that particular thing. At least you know that there is a mechanism, fail-safe mechanisms to ensure that our immune system will not attacking us. All right. Now, some of you might think, okay, ini year berapa? Year 1 ke, year 2 ke, year 3 ke, year 4?
Year 2.
Year 2. Okay, year 2. All right. Fine. Now, let's go back. Let me share with you some of my experience. When I did my PhD, I was working on microbiology, immunology, and I was one of the researchers that designed a vaccine for periodontitis. So, vaccine is part of my PhD project. And now, what I'm going to share with you is, some of you might agree with me. Some of you might, say, oh, I'm doing, maybe I'm explaining something that is totally unacceptable. Yeah. So I have no worry on that. I just want you to, take note that if you are disagree with me, you can raise your hands up. You can share anything of your thought. Because you are now in the university, you are no longer primary or secondary school students, or you are now already past the matriculation. So I hope that we will have more discussion rather than you just listening to my lecture. And on top of it, this lecture is recorded, so you can listen to this lecture again and again and again. So you don't have to worry about that. But what I really concern is that you should be able, by the end of this lecture, you should be able not only to remember, but also to understand. That is the most important thing. All right. It's already, no, actually I'm waiting for the rest to join us. So we have 32 participants, but it's okay. Now I am going to share with you my screen. Screen sharing. All right. Okay. Can you see my screen? Can you see my slide?
Yes.
All right. So if you can see my slide, alhamdulillah. Now I'm going to share with you. This is going to be, I think it's going to be a very short lecture. So I will take about less than 1 hour to explain to you all this. And then later we will have more towards discussion. If you have anything to ask, you can cut me in the middle. Yeah, so no need to worry. Okay, so today we are going to discuss about cytokines. What are cytokines? Okay, can I have Nadia Nurshifa? What do you think? What are cytokines? What is cytokines actually? What do you know about cytokine?
A group of protein.
A group of proteins. Okay. How about Intan Raihana? What do you know about cytokine? About Masturina?
I'm not sure if I'm correct. If I'm not mistaken, it's like when there are allergic reaction or something, the cytokines will be secreted by the immune cells.
Okay, it involves what we call allergy reaction. Yeah. Okay, what else? Maybe can I have Nabhan? Nabhan, what do you know about cytokines? If you have heard about cytokines before. Apa ni Dr. Hafiz masuk kelas tanya soalan dulu ni. Hai. Nabhan.
One of the product from the B cell.
Product of B cell. Okay. How about Zuliza? What do you know about cytokines? If you have read anywhere about cytokines. Zuliza? You are mute.
I'm sorry, Doctor. Suddenly my mic is not working just now.
Okay.
I think it's related to like Mas Surina just said, like is related to immune system.
Definitely, it is involved in the immune system because now we are studying microbiology, immunology, isn't it? This is immunology class, isn't it? All right. Anyway, yeah, thank you very much. Very, very excellent answers. Yeah, big applause to all of you. Okay, thank you. Yeah. So actually today I have another lecture actually with Kuliah Pharmacy because I'm teaching Kuliah Pharmacy, Allied Health Sciences, what else? Kuliah of Dentistry. So I'm actually my base is at the Kuliah of Dentistry. Actually today I have another lecture at 11:30 to 12:30 with Kuliah of Pharmacy. But I said to them that I'm going to postpone their lecture, make their lecture sometimes else, and then I just focus on you. I hope that you will listen to me carefully, and if you have any questions, just raise your hands up, just ask me in the middle of the lecture. Okay, do not ever worry. Okay, and then another thing is that, okay, I will tell you, I will give you some hint what is going to be part of your exam, which one is not. You know, you don't have to worry about it. What I want you to know, what I want you to have at the end of the class is you must understand all the things that I'm going to share with you. Okay, it is not about exam. If you want to pass your exam, inshallah you will pass. Okay, so far my students never fail, so you don't have to worry about that. Okay, what I really concern is that when you deliver or you explain to someone else, to them, you know, to anyone, wrong information, that will be, I think, a very big disaster. Yeah, so you have to understand my lecture carefully, not only mine, not definitely all other lecturers as well, but especially for my lecture, you must understand. Okay, understanding is the key. If you don't understand, ask me. Okay, fine. Right, now the learning outcomes from our topic, our presentation, from my presentation today. Number one, you should be able to understand what is the function of cytokines. Okay, we have various of cytokines, we have interleukins, we have chemokines, we have lymphokines, and many others. Right now, you should be able to understand what are their functions. Okay, each different cytokines, they have their different rules. Some cytokines, you know, different cytokines have the same rules. Okay, so that is the thing that you have to understand. What are the cytokines that involved in certain disease, what I call a progression of, like what your friend just mentioned to us earlier, allergy. Yeah. And then number two is that you must, I would like you to have at the end of the lecture, you must appreciate with the creation of Allah Subhanahu wa Taala, particularly on this, in this what I call lecture on cytokines, where at least you know that it is very important to have cytokines. Okay. But at the same time, cytokines can also cause problems to us. Like what happened, if you still remember, when what I call the first time we encountered with COVID-19, there are cytokine storms. Okay, cytokine storms where many of what I call the adults died because of cytokine storms. Because you know, because of the infection by COVID-19, it caused the cytokines to increase, you know, at a very high level, and then eventually causing, you know, people heart attack and many others, and eventually die because of cytokine storm. Okay, so at least you can link all this. Okay, now with the COVID-19, you should be able to link all this to the current situation you are having now. Now, what are the definition of cytokines? Yeah, so actually cytokines, like what I call the sisters mentioned to us earlier. Yes, it is true, it's a proteins, but it is a low molecular weight proteins, roughly about 30 kilodaltons. Okay, and when we talk about proteins, it's actually a collection of polypeptides. You know, we have peptides, and then after that you have a very long chain, we call it as a polypeptide, and eventually becomes a proteins. Okay, so this is cytokines are proteins which is a very short, what I call a very low molecular weight, a very, very short proteins, and it produced in transiently. So I put here in short time because it's quite, it can, you know, it produces a very, very short time, and it's the secretion is brief and self-limited. Okay, so it is not, you know, like I just mentioned to you earlier, some cytokines can have effect to many cells. Some cytokines are, you know, like affect only on one cell. Some cytokines affect on cells that is a very far distance. All right, which we are going to discuss in this lecture. Right. Next, it is also, okay, individual cytokines are produced by multiple cell types, like what called the brother just now mentioned, that B cells also producing cytokines. Okay, many cells are producing cytokines. Yeah, so and one cytokine sometimes can be, one type of cytokine sometimes can be produced by various types of cells. Okay, so these are some of the characteristics of the cytokines. All right, Shahmi. So far so good. Can you follow me?
Yes, Doctor.
Okay, am I being too fast?
No, it's fine.
Okay, okay. So if any one of you have a trouble or problems understanding my explanation, please let me know. Okay, you can cut me in the middle. Don't worry. Okay, adab is adab. But for me, the adab is if you don't understand, cut me in the middle. Okay, that is the adab. Okay, if you want to ask me at the end of the lecture and then that time, it will be a little bit difficult for me to recall which part actually you have the problems. But not to worry, if you have the problems after the lecture, is also fine. You can text me anytime. All right. So let's go back to the lectures. Okay. Now we have three types of cytokines. Okay. The first one we call it as lymphokines. Lymphokines. When we talk about lymphokines, I mean it is the cytokines that is produced by that is released by the lymphocytes. Okay. And we have also chemokines. What are chemokines? Chemokines is the cytokines that mediate chemoattractant. Chemo means chemical, attractant. So it attracts through chemical interactions. Yeah. So that is what we call as chemoattractant, or known as chemotaxis. Okay. So this chemotaxis occurred between cells. Okay. I'm sorry, there is a little bit of interaction. I'm now at home. As you can see, my background is actually in my home office. And my kids is out there. Anyway, and we have lymphokines, we have chemokines involving chemoattractant, and last but not least, we have interleukins. Okay, what are interleukins? Interleukins are the cytokines that produced by leukocytes. What are leukocytes? Leukocytes are white blood cell. Okay, leukocytes for regulating immune response. Right. So we have three types of cytokines. Sahira, can you tell me what are the types of cytokines?
The lymphokines, chemokines, and interleukins.
Okay, Ana Farhana, can you tell me what is interleukins?
Interleukins, it is leukocyte. Interleukins is a substance that has been produced by leukocyte, which one of the
Okay.
type of cytokines.
Okay, it is not substance, it's a protein, or cytokines. Yeah, so interleukins is cytokine. So you don't have to worry. Right, you just I already show you the slide. You just read now whatever on the slide. No need to paraphrase. Okay, what I want you to know is that okay, we have different types of cytokines. Okay, there are cytokines that's produced by lymphocytes. There are cytokines that is produced by leukocytes. There are cytokines that are actually involved in chemoattractant. So you can see, subhanallah, so Allah subhanahu wa ta'ala created various types of cytokines. So these cytokines are very important because they involve in the interactions, interactions between cells. Yeah. Okay. Now, we have here the general characteristics of cytokines. All right. So we have four general characteristics. The first one we call it tropisms. Second one we call it redundancy, synergy, and antagonism. Okay, redundant. Okay, what do you mean? What do you understand about redundant? Alia Aziz, what is redundant? In a very simple word that you can explain.
It occur, reoccurrency, then happen again.
Okay, dalam bahasa Melayu yang mudah sikit nak faham macam mana? Awak buat, saya pun buat benda yang sama. Betul? Do you agree, Fadilah? Fadilah, okay Fadilah. Okay, redundant ni kalau buat dua-dua, saya pun buat assignment sama, awak pun buat benda yang sama juga. Redundant lah tu. Betul Fadilah? Farhana Rosli? Are you following me?
Yes, Doctor.
Bukan, saya takut tiba-tiba internet saya tak berapa stable. So far okay
Okay, Doctor.
Okay. So sinergi tu macam mana pula Farhana? What do you understand about synergy? What is the meaning of synergy?
Buat sama-sama.
Buat sama-sama lah, buat assignment sama-sama kita berjaya sama-sama kan. Buat seorang-seorang tak berapa nak bagus. Kalau kita buat dua orang, jadi lagi baik. Kan, that is synergy kan, bahasa kita. Kalau antagonism pula, kalau ni apa, Mizan Kamalina. Antagonism pula apa kalau kita punya bahasa? What is antagonism?
Bertentangan.
Betul. Kan yang kita tak berapa nak clear sekarang tropism je. Tropism tu, what is tropism? Okay, so at least you understand redundancy bila kita buat benda yang sama. Awak buat juga, saya pun buat benda yang sama. Kita buat benda yang sama. Ni semua ni duk belajar dengan saya ni kira redundant lah ni, semua belajar topik yang sama je. Okay, sinergi kita buat assignment sama-sama kita berjaya lebih baik. Antagonism, tengok kawan dengki, aku jatuhkan hang jatuhkan aku. So that is antagonism. Okay, now what is that correct, the definition of redundancy, synergy and antagonism for cytokines? Okay, let's go one by one. Okay, we go with tropism. So what is tropism? The tropism is one type of cytokines. Okay, one type of cytokine, jenis cytokine yang sama. Okay, satu jenis cytokine may act on several different cell types. Okay, one cytokine act on several different cells. Okay, all right, that is definition. Now let's go look into this figure. Okay, so you can see here, this is T helper cell. Okay, activated T helper cell. Okay, when we say it is pleiotropy, it means that, say for example, this T helper cell produce interleukin 4. Okay, interleukin 4, and this interleukin 4, okay, is used to activate, proliferate, and differentiate B cell. It is also used to proliferate thymocyte. The same interleukin 4, it can also affect on mast cell by induce the proliferation of the mast cell. See, it affects on 3 different cells. Interleukin 4 works on B cell, works on thymocyte, and works on mast cell. So this one, when we have one similar cytokine, it affects on different cells. So this is what we call as tropy, pleiotropy or protropism. Okay, so one type of cytokines, okay, one type of cytokine acts on several different cell types. Okay, type 1, type 2, type 3, or whatever types you want to say, type A, type B, type C. Okay, so 3 different cell types with one single cytokine. Okay, Imaduddin, faham Imaduddin?
Faham, insyaAllah.
Alhamdulillah. Bagus. Suka saya tengok senyum pakai kepiah. Kita dua je lah yang ada gambar je. Ada lagi yang share gambar ni. Tak ada dah. Semangat sikit kan? Kalau tak macam cakap seorang-seorang je saya ni. Anyway, it's okay. Now, let's look into this redundancy. Alright. So when we talk about redundancy, what is the meaning of redundancy? Macam saya cakap tadi lah. Okay, redundancy when we have different individuals, also in this case different cytokines, okay, have the same effect. Okay, have what we call different cytokines. It has what we call different, supposed to have different, but now it has the same what we call that effect. Okay, you do the same assignment, I do the same assignment. Okay, so we call this as redundant. All right. Now, let's look into this figure. So you can see that this activated T helper cell, okay, it produces interleukin 2, interleukin 4, and interleukin 5, where all these 3 interleukins, they work by inducing B cell to proliferate, okay, to proliferate membiak, okay. So proliferation occurred when there is interaction, when there is a release of interleukin 2, 4, and 5. So you can see interleukin 2 the role is to induce the proliferation of B cell. Interleukin 4 is also to induce the proliferation of B cell. Interleukin 5 also the same thing. So all these 3 interleukins, we call these as redundancy. Okay, redundancy. All right. Now, how about the last one? We have synergy. What is synergy then? Synergy, when we have 2 or more different cytokines, may have a greater than additive effect. Okay, let's look into the figure. I might be clearer. So if you look into this figure, what we can see here is that the T helper cell will produce interleukin 4 and interleukin 5. So this interleukin 4 and interleukin 5, when they are together, it will induce class switch to Ig of the B cell. I'm not sure whether you have heard about whether we have listened to the lecture on cell-mediated and humoral immunity. Dah belajar ke? Alia Aziz, have you had a lecture on cell-mediated immunity and humoral immunity?
Not yet, I think.
I think.
Saya rasa doktor. Sudah.
Dah ke belum? Dah.
Sudah dengan Dr. Effendi kalau tak silap.
Okay. Baik, saya cerita sikit lah. Okay, let me explain to you just because immunology it is actually a study or what I call a course where you need to understand from one because it is a cascade. Dia adalah satu jalan cerita. Kalau kita sangkut kat tengah-tengah, kita nak patah balik susah. Okay, baik. Sebab saya ada experience yang sama jugalah. Samalah macam kamu. I was a student before. We are exactly the same. I was not born, with my PhD. Okay, I was exactly like you. Okay, and during my undergraduate, I have problems to understand. I have a problem to understand immunology. Okay, because I'm not good at immunology during that time lah. And when I did my PhD, my master's was on immunology. So you can see something that I don't like so much, but eventually I become, the expert on it. But my dear brothers and sisters, let me explain to you just a little bit on this cell-mediated and humoral immunity. Okay, cell-mediated. Okay, so you have a first line, innate immunity, and we go to the second line, which is what we call the cell-mediated or humoral immunity. Okay, or these two we call it as adaptive immunity. Okay, mula-mula innate, lepas tu di bawah dia ada adaptive. So under adaptive, we have 2 types of adaptives. Number 1, we call it as cell-mediated. Okay, dia bergantung kepada cell. And another one is humoral. Okay, humoral doesn't mean humor lawak-lawak. No. Humoral means something that involves antibody. Okay, that involves antibody. If you still remember, maybe you have heard about MHC, major histocompatibility complex. If you can imagine that, if COVID-19, SARS-CoV-2, now they enter the body, okay, what will happen? The antigen presenting cell will engulf this SARS-CoV-2, the virus. And then what happened is that these virus, engulfed by the antigen presenting cell. Okay, and then this antigen presenting cell will produce the proteasomes and everything, and it will chop this virus. Okay, become a small peptide, and this peptide will bind to the MHC class 2, and it will be presented on the surface of the APC, antigen presenting cell. All right. When it is presented on the antigen presenting cell, now we want the B cell comes in because we want this B cell to produce antibody specifically to the SARS-CoV-2. And then comes a B cell, okay, with the information there, but it is still naive, okay? Naive maksudnya tak ada ilmu lagi. It is already matured, dah matang, but naive. Okay, macam inilah Farah, Sahira, Raudah, Syafiqah, semua dah akil balik dah kan. Semua dah matang dah, tapi naif. Naif sebab apa? In this case, you are still naive on cytokines. Because you don't know what is cytokines, you are still naive. Naif ni macam tak ada ilmu ni. Okay, kita dah matang tapi kita belum ada ilmu. Now we want to give information to what I call this APC, antigen presenting cell, want to give the information on SARS-CoV-2 towards B cell, so that this B cell can produce antibodies specifically to SARS-CoV-2. So when T helper cell, say for example, it requires IgE, then T helper cell, look at this figure, this T helper cell will produce interleukin 4 and interleukin 5, where if these interleukins together, they will give instruction to B cell. Okay, B cell, you have to have a specific antibody targeting this virus, and I want you to produce IgE. Okay, when I interleukin 4, interleukin 5, what happened? B cell got all this information. Yes. Okay, T helper cell comes to me. Okay, major histocompatibility complex also binds to me with all this information. Now I have to produce what? I have to produce IgE. So activated T helper cell, okay, will give information to the B cell to produce IgE by producing interleukin 4 and interleukin 5. How about if it is only interleukin 4? So if it is only interleukin 4, it becomes like this. It will only induce the proliferation. Okay. If you look into the previous one, it can also activate or differentiate or proliferate the B cell. So you can see here, subhanAllah, Allah creates, what is it? A what do you call it? Fail-safe mechanism. Sebab apa? To activate the cell, it is not only the major histocompatibility complex that will activate, not only APC, antigen presenting cell, will activate the B cell, but also the helper T cell will also involve in the activation of B cell. In this case, interleukin 4 and interleukin 5 will give an instruction to the B cell, please prepare the armor or prepare the the bullets, which the bullets is IgE. Okay, so that is the story of synergy and cell-mediated as well as humoral immunity. Yeah. Okay. Azhar, do you understand what I just my just now?
Yes, I understand.
If I ask you to tell me the story again, can you tell me the story?
I think only the last part I can tell.
Okay, how about Shikin Zawawi? Can you understand my story?
Yes, doctor.
Yes. Okay. Nanti kita akan buat exercise. Exercise bukan pumping lah. Kita akan buat exercise. Kita nak tengok yang mana yang faham, yang mana yang tak faham. Kita tulis sikit-sikit je. Kan? Nanti baru kita tahu kita faham ke tak. This session is recorded, so you can keep on listening to my lecture again and again. I'm so sorry I have to use most of my lecture in English because that is the instruction from the university. But again, I will mix in both languages so that it will be easier for many of us to understand or to get the gist of the lecture. But not to worry, okay? Okay. We have another one. We have antagonism, as many of us has mentioned to you, mentioned earlier. So antagonism means, when they are fighting each other. So cytokines that inhibit the action of another cytokine. Okay. So if you look into this figure, what does it mean here? Okay. Antagonism, the activated T helper cell. Okay. This T helper cell is already activated. Okay. And it produces interleukin 4. If you still remember, interleukin 4 supposedly, okay, interleukin 4 plus interleukin 5 induce switch to IgE. Interleukin 4 is also involved in proliferation, also involves in activation, proliferation, differentiation of B cell. Now, for the antagonism, interleukin 4, okay, and comes out from the activated T helper cells in interferon gamma. So what happened to this? Okay, instead of causing class switch to IgE, okay, now the presence of interferon gamma will stop interleukin 4 from producing IgE. Yeah, because IgE is also involved in what? What do you think? IgE is good, but if it is too much and it involves in allergy. Yeah, right. So activated T helper cell knows, okay, I think it is enough for the B cell to produce IgE, so we have to stop it. Okay, how do we stop it? This activated T helper cell will release the interferon gamma. Okay, so this is another fail-safe mechanism to ensure that our system, our body is still maintained. Yeah, so we don't want the immune system to attack ourselves. So this is the subhanallah, this is Allah's creation. So we never thought that this is actually happening in our body. We know that okay, that we have immune system. So what are the functions? What are the roles of immune system? We don't care about it. You know, today, alhamdulillah, we know, we have the knowledge. So I hope that you can appreciate every single thing that Allah has been created for us. Yeah. Now let's talk about action of cytokines. How cytokines action? Right. So there are three actions here. Number one, autocrine. Okay. Not Autobots. If you maybe some of the brothers know or sisters know, Transformers. So this is not Autobots, it's autocrine. So when we talk about autocrine, it means cytokines that bind to receptor on the cell that secrete it. Okay, means that, say for example, if ni buruk siku lah ni, kalau bahasa kita, dah keluar ambil balik. So that is the meaning of autocrine. Yeah, so the cytokines, they release the cytokine. Okay, the cells release the cytokines, but it turn back to the it bind back to the receptor of the cells that produces cytokine. So that is called autocrine. All right. So how about the paracrine? Paracrine is when the cytokines bind to the receptors on nearby cells. So okay, cell next to the next to it. All right, and the cell that is very, very close to it. Yeah. So that one we call as paracrine. Paracrine. Right. And the last one we have endocrine. Okay, what is endocrine? Endocrine involves the cytokines that bind to the cell in the very far away. Okay, the distance part of the body. So for example, the cytokines from the brain go to the muscles, go to, a very long distance. Okay, so this is what we call as the endocrines. We have autocrine that binds to the cell, what we call the receptor. Paracrine binds the receptor on the nearby cell, very close to the cells that produce the cytokine. And endocrine, and it binds to the cell that is a far away, a very distant part. Yeah. Okay. This is how I would like to explain to you in the figure. If you look at this, so this is a cell that produces cytokines. Okay, and these cytokines bind back to the cell. Okay, this is a specific receptor, and it binds to the cell. Yeah, so when it binds to the same cell, we call this autocrine. But when it binds to the nearby cell, we call this paracrine. How about if it goes into the circulation? So this is a distant cell, then we call this as endocrine action. Endocrine action. All right. Now, I would like to have Fadilah Fauzi. Apalah Dr. Hafiz ni, asyik tanya soalan je. Okay, can you tell me what do you understand about paracrine?
Dengar tak?
Dengar.
Okay, paracrine secrete and go to nearby cell.
Okay, go to nearby cell, right? They bind to the receptor of the nearby cell. All right. How about, okay, now can I have Liana, okay. Okay, how about autocrine? What is autocrine?
Cytokine, cytokines to binds to receptor yang sel yang secret dia.
Okay, excellent. Okay, we have Nabhan. Nabhan, can you tell me what do you know? Do you understand about endocrine action?
Endocrine is a cytokine bind to the cell in distance.
Pandai ni. Saya boleh berhenti dah lah. Tak payah ngajar lah kas ni. Pandai sangat dah. Alright. Jangan stres-stres kita belajar sambil-sambil kita cuba memahami insya-Allah. Alright. So far so good Mizan? Boleh follow lagi?
Boleh.
Boleh. Bagus. Alright. Now, let's go to the next slide. So we have here general functions of cytokines. You know that, subhanallah, Allah created everything. That's why in Allah subhanahu wa ta'ala mentioned in Al-Quran, what is it? Tidak aku jadikan benda ni Rabbana ma khalaqta hadha batila subhanaka faqina adzaban nar. Rabbana ma khalaqta hadha batila. Maha suci Allah, Rabbana ma khalaqta hadha batila. Allah Subhanahu wa taala never created something that has no function, that has no rules, So everything Allah create, the creation of Allah Subhanahu wa taala, there must be a function, must be a rules over there, Wa ma Rabbana ma khalaqta hadha batila subhanaka faqina azaban nar. Maha suci Allah. Kita minta kepada Allah Subhanahu wa taala pelepasan daripada azab api neraka. Anyway, my dear brothers and sisters, what are the functions of cytokines? How about if we don't have cytokines? So the thing that will highly affect it is the immunity. So because cytokines are the key factors for the innate and adaptive immunity to run perfectly. So that is one of the reasons. It involves in the immunity. It involves in the immune response. Okay. Apa nama Farah? Copy balik dia punya attendance. Saya takut ada yang terlupa nak sign attendance.
Okay.
Sekejap saya nak tengok berapa ramai yang dah sign attendance. 35 participants, so we have 35. Okay, 35. Alright, Alright. Number 1, innate and adaptive. Remember, innate is the one that involves macrophages, neutrophils, basophils, eosinophils, all the fields tu lah. Adaptive pula involves T cell, T helper cell, memory T cells, cytotoxic T cell. Cytotoxic T cell is also known as CD8. T helper cell also known as the CD apa? CD4. So we have B cells, the one that involves in also part of the adaptive. So remember, adaptive, there are two types of adaptive. Number 1, we call it cell mediated. Number 2 is humoral. All right. Now, on top of immunity, it also involves in inflammation. As I just mentioned to you earlier, okay, certain antibodies is also involves in inflammation. Also cytokines. Cytokines can also involve in inflammation. Because it regulates the amplitude and duration of the inflammation. Okay, that is why when people talk about COVID-19, previously there is a report on cytokine storms because of it involves in inflammation. Right. It is also involved in the communication between cells, which we have been discussing previously. Paracrine, Autocrine, what else? Tak ingat dah, saya lupa dah. Endocrine. Okay, so communication between cells. And the next one is hematopoiesis. What is hematopoiesis? It's a production of blood cells and platelets. Okay, cytokines also involves in hematopoiesis. So you can see here the cytokines are very, very important. It involves almost in every aspect of the immune system. All right. General cytokine generating cells. So we have various of cells that generates or produce cytokines. For the innate immunity, it involves macrophages, endothelial cells, epithelial cells, fibroblasts, dendritic cells. And for the adaptive immunity, it involves T lymphocytes, macrophages, NK cells, and mast cells. Okay, so these are the cells that can produce cytokines. How about which one is the cytokines that involves in the mediators of innate immunity? Okay, remember innate immunity, it is not yet involves what we call T cells and B cells at the beginning, the first line defense. So the mediator for innate immunity, okay, include tumor necrosis factor, interleukin 6, 7, 8, and interferon gamma. Okay, try to remember at least one or two of this. Okay, so interleukin 6, 6, 7, 8, TNF and interferon gamma. So these are the mediators for innate immunity. Okay, so we have interleukin 1, interleukin 12, 6, alpha, interferon beta, TNF alpha. Okay, these are the roles. What are they involves? Okay, yeah, for the innate immunity. Now, there are also some cytokines that involve in the mediators as a mediator for adaptive immunity. Remember, adaptive immunity, there are two types of adaptive immunity, humoral and cell mediated. Yeah. Okay, so for the mediator of adaptive immunity, it produced mainly by T lymphocytes. Okay, by T lymphocytes. All right. So how does it act? It acts on the lymphocytes. Yeah. Okay. And it will induce a growth and differentiation. If you still remember when I showed you the figure of the activated T helper cell that produces interleukin 4, interleukin 5, yeah, all of them are actually mediate what they call the B cell. Yeah, so it is something that mediates what they call the adaptive immunity. So very easy if you can remember the figure just now. So it will be easier for you to remember this one as well. Okay, it acts on effector cells. Effector cells mean the cells that has been activated, the T cell that has been activated. Yeah, so we have, say for example, when the T cell binds to the MHC class 2. Okay, if you can imagine. Okay, T helper cell bind to MHC class 2. Now it becomes effector T helper cell. Okay, so or the B cell, one will become a memory B cell, another one we call it as plasma B cell, or it's actually an effector B cell. Okay, but you know, for the in immunological term, we didn't call it as effector B cell. Instead, we call it as the plasma cell. All right. And these are divided into activator of cytotoxic response. Cytotoxic response means what? The CD8, okay? And activator of humoral response. So this is what we call that the B cell, okay? So this is going to be the B cell activators, right? Look at this, we have interleukin 2, okay? Okay, and then this interleukin 2 will involves in the T cell proliferation. Interleukin 4 promotes T helper cell, T helper 2 to differentiate. Okay, T helper 2 again for the interleukin 5. Okay, activation of eosinophil and so on. All right. Since you have learned about cell mediated, I would like to ask any of you if you can tell me what is the difference between T helper 1 and T helper 2. Okay, I give you 5 minutes. Okay, try to Google what is the difference between T helper 1 and T helper 2. I will ask you in 5 minutes. Okay, let's take a break. You do a little bit of Google, find what are the differences between T helper 1 and T helper 2. Okay, 5 minutes from now. We'll meet again at 12 o'clock. Okay, selamat mencari. Mas Turina, so far so good?
Alhamdulillah.
Alhamdulillah. Ashikin okay, Nur Ashikin Zawawi.
Alhamdulillah, I'm good.
Kalau ada yang sangkut-sangkut ke nampak macam kelabu-kelabu asap tu, bagi tahu cepat-cepat. Jangan malu, semua orang tak pandai. Saya pun start dulu tak pandai juga. Sekarang ni pun bukan pandai mana pun, tapi boleh lah sikit-sikit sembang. So we have 3-4 minutes. 3 to 4 minutes. All right. Now, can I have Shasha? Shasha, what is the difference between the T helper 1 and T helper 2? Shasha Shafika. Can I have Shikin Zawawi? What do you think? What is the difference between the two? T helper 1 and T helper 2.
Basically, T helper 1 cell generate immune response against intracellular parasite, for example, bacteria and virus, while T helper 2 cell generate immune response against extracellular parasite, for example, helminths.
Okay. How about Masturina? Do you have other information?
What I read here, the overactivation of T helper 1 cell can cause autoimmunity, while for T helper 2 cells can cause allergy. Yes.
Okay. How about Asma? Asma.
Okay, so for the T helper cell, if it will mainly activate the cell mediated immunity, while the T helper 2 cell will mainly activate the humoral immunity.
You can see the more you read, the more information that you gain. So this is what we call a synergy. So everyone knows that there are lots of functions, various so the one that is what we call involves in internal, the external of cells, and we have someone explain to us involves humoral and cell mediated immunities. But basically, yeah, T helper cell, they have various of roles and function. And on top of it, we have T helper 1 and T helper 2. All the, what I call answer that I have given is correct. Yeah. So, subhanallah. All right, now let's go back to the lecture. So we have various of what I call cells activated with interleukins, various types of interleukins. Or in this case, is adaptive immunity. All right. There is also what I call the activator for the cytotoxic response. Okay, in this case, it induces macrophage cytotoxic T cell and activate NK cell, natural killer cell. And members include interleukin 2, 3, interferon gamma, and lymphotoxin. All right, and then there are also the what I call interleukins that involves in humoral response. Okay, so this is cytotoxic. Okay, CD8. Okay, this is humoral response of B cells, involves in the activation of the B cell, which include interleukin 2, 3, 4, 5, 6, GF. Okay, transforming growth factor beta and interferon gamma. Okay, 2, 3, 4, 5, 6. So all of these involves in the what I call humoral response. Okay, 2 and 3 involves in cytotoxic. 2, 3 interferon gamma. So this is 2, 3 interferon gamma 2. Okay, so interleukin 4, 5, 6 on top of it involves in activators of humoral response. Easy to remember. 2, 3 interferon gamma activate humoral response as well as cytotoxic response. Right. So we have here activator for inflammatory cells, and we have interferon gamma involved in it. All right. How about the stimulators of hematopoiesis, the production of the blood? Okay. So we have here produced by bone marrow stromal cell and leukocyte. Yeah. And it stimulates growth and differentiation of immature leukocytes. Immature, yang belum matang lagi, yang belum akil balik lagi. All right. And then, and the members of the group that involves in stimulating the hematopoiesis will be interleukin 3, 7, and CSF, colony stimulating factors. In the exam, if you want to answer CSF only, it's enough. Okay, you don't have to write in full. Okay, so you just write down CSF, GM-CSF, M-CSF, G-CSF, enough. You don't have to write granulocyte, monocyte. So, it's very long. Okay. If you want to answer, like that, it's also okay. And then you don't have to worry if you spell incorrectly. Yeah? Okay, your spelling is, too bad. As long as I can understand, it is acceptable. Yeah, because this is not English lecture. Okay, I'm not teaching you English. I'm teaching you immunology. Okay, so don't worry. In the exams, I don't care about your spelling, your grammar. It is past tense, present tense. As long as I can understand, that is enough. Okay. Specific function of cytokines. Okay, I'm sharing with you some of the cytokines on top of interleukin 2, interleukin 3, which we already explained to you in the beginning of the lecture. We have also interleukin 1, where this interleukin also have its specific function. Interleukin 1, for example, it activates T cells and B cells, neutrophils, epithelial cells, and fibroblasts. As you can see here, interleukin 1 involves in various of cells. Okay, so if it is various of cells, what type of these interleukins? If you still remember, what are the types of this interleukin? One khairul bariyah. Ingat tak? Apa dia type cell ni? Interleukin ni? Or cytokines ni? Yang dia boleh efek pada banyak sel. Shakira, ingat tak?
Tropism.
Ya?
Tropism.
Okay. Kita tengok betul tak? Tropism maksudnya interleukin 4 dia efek pada banyak sel. Okay, redundancy banyak-banyak satu sel. So jawapannya adalah tepat sekali, 100 markah. Okay, betul. Okay, nampak senang je kan? Okay, kat mana tadi? I think we are somewhere here. Yeah. Okay, it activates T cell, B cell, neutrophils. It also activates T cells to produce interleukin 2. Activates T cell, and T cell becomes and then tell T cell, okay, you have to produce interleukin 2. It is also an endogenous pyrogen. All right. Now, interleukin 2. Okay, this one, interleukin 1, activate the T cell, produce interleukin 2. Then what is the function of interleukin 2? Interleukin 2 is produced by helper T cell. Okay, so this is helper T cell. Okay, so it produced by helper T cell. Helper T cell is also known as CD what? CD Shikin. CD apa Shikin?
CD4.
Pandai. Okay. Bagus. Boleh ganti saya dah apa ni Shikin? Shikin? Boleh Shikin?
Tak ada.
Boleh ganti saya. Tak ada, gurau je. Alright, boleh So kita tengok So CD4 ini CD, okay, stimulates both helper, okay, interleukin 2 stimulates helper and cytotoxic T cell produced by helper T cell, but it also stimulates the same cell. So what action is this? Stimulate cytotoxic T cell, okay, but stimulate the helper T cell itself. What action is this? Nabhan. What action is this? What action of cytokines is this? Kalau tak tahu, kalau tak ingat, boleh pass kat orang lain. Sebut je nama. Banyak nama di sini.
Maaf Dr. saya tak sure.
Sebut satu nama.
Satu nama. Ya.
Tu banyak 33 tu. Dengan dot leaf
Sebut Imat lah Dr.
Okay, Imat. Apa dia Imat action dia? What is the action of cytokines? Involves here.
Autocrine.
Autocrine, pandai. Okay. So this is autocrine. So interleukin 2 give instruction to interleukin 2. Interleukin 2 gives instruction to T helper cell that produce the same interleukins. Okay. So it stimulates both helper and cytotoxic T cell. Okay. And it also involves in interleukin 2 acts through the induction of a specific receptor, interleukin 2 receptor on the cell surface, and interleukin reacts in combination with interleukin 4 to stimulate growth of B cell. So 2 plus 4 stimulates growth of B cell. Okay, so this is, what is this? Interleukin 2 and interleukin 4. They have to work together to stimulate growth of B cell. What do you think is this? Intan Raihana. So you need interleukin 2 plus interleukin 4 so that so B cell can grow.
Sinergi.
Betul. 100 markah. Pandai. Alright. We've done the interleukin 2. Now let's go for the next one, interleukin 3. Alright. So interleukin 3, when we talk about interleukin 3, so produced by activated helper T cell. So we have here helper T cell, interleukin 2. Interleukin 3 also produced by helper T cell. Okay, and interleukin 3 is important because it supports the growth and differentiation of stem cell in the bone marrow. Okay, so interleukin 3 is very important here. Okay, how about interleukin 4, interleukin 5? Interleukin 4, interleukin 5 are proteins are produced by helper T cell again, and mast cell. So mast cell will only be interleukin 4. Okay, interleukin 5 is not, it is produced by T helper cell. Yeah, and this interleukin 4, interleukin 5 will promote the growth and differentiation of B cells. Okay, so you just take out this respectively. Sorry. So interleukin 4 promote growth, interleukin 5 promote differentiation. Okay, And interleukin 4, okay, enhance humoral immunity by increasing number of T helper 2 cell, okay, interleukin 4. So I think one of the sisters just now mentioned that T helper 2 involved in humoral immunity. Yeah, so it is true. Okay, interleukin 4 here is very, very important to induce the B cell. Yeah, and then we have interleukin 4 also required for the class switching, okay, of IgEs and enhance of IgS, Igs. Igs means immunoglobulins, antibodies. Okay, enhance the production of the IgE. Yeah, and interleukin 5 increases IgA production. IgA production will be interleukin 5, IgE will be interleukin 4. Okay. All right. So we've done that. Now we go for interleukin 6. Okay. Interleukin 6, on the other hand, is produced by macrophage and endothelial cell. Okay. And what is the role of the interleukin 6? It stimulates B cell to differentiate. Okay, it stimulates B cell. And it also involves in inducing fever. Okay, inducing fever. So you know that when you are having fever, so you might have lots of interleukin 6. So because interleukin 6 is also involved in what we call inflammation. Yeah, so that's why you have, someone's having fever will have high what we call interleukin 6 production. All right, and causing increase of the temperature. And it also induces the production of acute phase proteins by liver. All right, now let's go to the next interleukin. So we have interleukin 10 and interleukin 12, where these both interleukins involved in the production of T helper 1. Okay, so that is why I asked you what is the difference between T helper 1 and T helper 2. Whereas interleukin 10 is it involves in the production of T helper 2. So interleukin 10 involves in T helper 1 and T helper 2 production. Okay, and inhibits the development of T helper 1 by limiting the production of interferon gamma. Okay, so at certain level, this is another fail-safe mechanism. So, because if they want to limit the what do you call it, the number of T helper 1, so how does it limit? It will limit by what I call the by decrease the number of interferon gamma. Okay, production by the what I call okay, it will have what I call antagonistic effect. Okay, interleukin 10, okay, will limit the production of interferon gamma, antagonistic, antagonism. So how about interleukin 12? Okay, interleukin 12 also is produced by macrophage and the dendritic cell, okay, and promotes the development of T helper 1. So I think this is similar to what I have mentioned to you on the first point. So the only different thing here is that interleukin 12 is produced by macrophages and dendritic cell. Okay, so this is an antigen presenting cell, a dendritic cell. So it produced by the antigen presenting cell over here. All right, interleukin 13. Okay, so we have 4 more. Okay, the list of interleukins. All right, so interleukin 13. Okay, interleukin 13 on the other hand, it is produced by T helper 2. Okay, T helper 2 cell, and it is one of the main mediator of allergic airway disease. Okay, remember this. Okay, when you want to, because there is also lecture on hypersensitivity. Okay, which we'll discuss on the asthma, and one of the interleukin that is very important over here is the interleukin 13. Okay, interleukin 13 involves in asthma. How does it involve in asthma? Because it associates with airway hyperresponsive in asthma. Okay, and it has no effect on IgE production, doesn't have a role on it. All right, how about TGF beta? TGF beta is one of the cytokines that produced by many types of cells. Many types of cells produce one similar cytokines. Okay, including macrophages, T cells, B cell. And this TGF-beta is also known as anti-cytokines because it inhibits many function of macrophages, B cell, neutrophils, and natural killer. Okay, that is one why it is the TGF-beta is cytokines that is also known as the anti-cytokines because it inhibits all these things. Yeah. Do you know that B cells is also antigen presenting cell? Okay. B cell also able to engulf, okay, are able to phagocytes, okay. On top of producing antibodies, it also involves in what we call as the antigen presenting cell. All right, it's unique, isn't it? It can produce antibody. It is the same time. It is also cells that engulf it can also works as the phagocytes. All right. So TGF-beta inhibits the growth of and the growth and activities of T cell. Okay, so inhibits macrophage, B cell, neutrophils, natural killer, and as well as the T cell. Okay, so if I ask you what are the TGF-beta will inhibit the T cell, B cell, macrophage, neutrophil, and NK cell. Okay, that is the reason why TGF-beta is also known as the anti-cytokine. All right, and it involves in wound healing. Yeah. And we have here tumor necrosis factor. So it activates phagocytic and killing activities of neutrophils. Okay, so these neutrophils, these TNF, these cytokines will activate phagocytic activities. Okay, will give instruction to neutrophils. Okay, so we have to kill these microbes. We have to kill these pathogens, for example. Yeah. And it also increases the synthesis of adhesion molecules by endothelial cells. What happens when there is a what I call adhesion molecules? It will induce the extravascular migration of neutrophils. Okay. All right. So last but not least, we have TNF alpha. So what are the function of the TNF alpha? So TNF alpha, one of it involves in the extravascular migration. Okay. And it involves in it activates a respiratory burst within neutrophils. It enhances lymphokines production by the help of T cells, stimulates growth of T cell, and it involves in high concentration mediate endotoxin induced septic shock. Okay, now I know there are lots of cytokines here that you have to remember, but I don't really like you to memorize all these cytokines. At least you know that there are cytokines involved in like a certain thing. What I want you to remember is that at least you know what are the cytokines specific, what are the cytokines involved in stimulators of hematopoiesis, activators of inflammatory cells, activator for humoral and cytotoxic. Okay, you don't have to worry what are the function of each and every of the interleukins. It is a crazy thing to memorize all this. Better for you to memorize Al-Quran and Hadith rather than memorizing all the rules and function. Even I am a lecturer, explaining to you all this thingy. Trust me, I also don't remember all this. What I know is that interleukin 6 and interleukin 8 are very important for my field because it involves in cancer development. It also involves in killing the cell, the cancer cell. That's all. To remember all this, I think on top of it, maybe you can remember the figures just now, which I mentioned to you, interleukin 4 plus 5 is what? Okay, remember all the drawings and so on. If I ask you to, if I ask you this question, then I think I'm not a good lecturer. Because as a good lecturer, even the lecturer also cannot memorize this. How can you expect the student to memorize? This is not off record, but it's okay. At least you know that I am not crazy enough to give you such question. All right, now let's go to this. Earlier we are discussing on the roles and function of each cytokines. But how about the receptors? Okay, we have we have been discussing on the autocrine, paracrine, endocrine, and we have been, we have sisters explaining that, okay, these are the receptors and so on. Yeah, it's true. Okay, now let's talk about the receptors. Okay, so we have the receptors, and when there is a receptor, there will be signal. Okay, and for the cytokine receptors, it is actually a multimeric. What does it mean by multimeric? It means multiple polypeptide chain. Okay, so the receptors will be multimeric. the common signal transducing subunits, it will be producing signal, okay, and each of these are very unique with high affinity subunits, and with high affinity subunit, which is also associated with the activation of target cell, okay, a very high affinity, you know, right. And when we talk about the receptors, so we have various, or we have families of cytokine receptors. Now we are going to discuss on the receptors pula. Okay, just now we are discussing on the interleukins itself, yeah, the cytokines itself. Now we are going to discuss on the receptor for the cytokines. Allahu Akbar, doktor banyaknya nak kena ingat ya. Nak buat ke mana, itulah dah student kan. Tanya saya pun tak ingat. But at least I try to assist as much as possible lah. But please do not ask me what are the questions that will come out in your exam. That will be not fair lah kan. But at least I have been giving you some hint, but not try to make use of it. Hint pun saya pun tak prepare lagi soalan exam ni, sekali tak keluar. Jangan marah lah ya. Because I am not giving you the question. Then this recording, sometime I don't know, today everything is recorded, yeah, and then you pass to someone dengki with me and then give to the deputy dean, habis saya hari ini kerja, esok kena berhenti dah. Alright, anyway, just making fun. Right, okay, now we have what I call family cytokine receptors. We have 5 families, yeah. Okay, number 1, we call it as a class 1 hematopoietin. Hematopoietin, class 2 interferon, immunoglobulin superfamily, TNF, okay, tumor necrosis factor receptors, and chemokine. Okay, chemoattractant cytokines, yeah. So we have these 5 family cytokine receptors. All right, I know there are lots of ligands. Okay, ligands mean, you know, the attachment site. Okay, so ligands for what? Ligands is the receptor for what? Yeah. So for receptor class 1, family class 1, also known as a hematopoietin. So this is how it looks like. It would be great if you can remember how the drawing it looks like. Okay. Now you can see here there is a difference between the classes. Class 1 is we have conserved cysteine, and then we have here what I call class 2. Okay, we have class 3. This is immunoglobulin, and we have TNF, and we have chemokine. Okay, so 1, 2, 3, 4, 5. If you can remember a little bit on the figure would be excellent. And then some of the lines, maybe 3 or 4 of the ligands. Okay, this is going to be very simple to you remember. Class 1 hematopoietin will be ligands. The ligands will be like interleukin 2, 3, 4, 5, 6, 7. Okay. Maybe the rest is a bit difficult for you to remember. At least you remember 2, 3, 4, 5, 6, 7. Takkan tak ingat kot nombor 2, 3, 4, 5, 6, 7. Kan? And then jump sikit, 9. Up to you lah, as long as you can remember a few of them. It will be excellent. Okay. And then receptor family class 2 interferon. So interferon, okay, because the name is interferon, it will be easy for you to remember as well. Interferon alpha, beta, gamma. This will be interleukin 10, 19, 20, 22. At least you remember all these 3 is excellent already. Okay, with a little bit of the figure. All right, so at least you know that they are very specific. Okay, and there is also receptor that is specific for the immunoglobulin, and the ligands will be interleukin 1, MCSF, okay, c-KIT, and interleukin 18. Okay, and then you can have also TNF. Okay. So just now is the interferon alpha, beta, gamma. And for the TNF will be TNF alpha, TNF beta. Okay. And there is also CD27, 30, 40L, okay, and GF and FAS. At least remember this, okay, TNF alpha, TNF beta, okay, and CD what? Any of it. Okay, 3 is enough, 3 or 4. All right. And the last but not least, we have chemokine. And for the chemokine, will be interleukin 8, Rentes, MIP1, TF4, MCAF, and NET2. Okay, so this will be the drawing of the the receptor for family chemokine. All right, now we have the cytokine, we have the receptor. What happens if the cytokine binds to the receptor? So what will happen is that once the cytokine binds to the receptor, okay, it will activate JAK. JAK stands for Janus kinase, JAK, okay, JAK family, tyrosine kinases. Okay, so JAK kinase in short. Okay, phosphorylation of receptor. So meaning that it binds and then it will phosphorylate the tyrosine. Okay, cytokine binds activates JAK. Okay, JAK kinase, Janus kinase, and this will induce the phosphorylation of the tyrosine. Okay, tyrosine phosphorylation of STAT. Okay, by JAK kinase. JAK kinase activated, and then the tyrosine will be phosphorylated. Okay, the tyrosine will be phosphorylated. What will happen that they will induce the binding of STAT. So this is number one STAT, this is STAT2. So this STAT, okay, when it is activated by JAK kinase then is a phosphorylation of the tyrosine. So these two STATs will bind. Okay, so these two STATs will bind when there is a binding of STAT. STAT is signal transducers and activators of transcription. So when they bind, okay, bind here means dimerization means bind. Okay, so when they bind, it start to translocate and get into the, what is this? To the nucleus. Okay, when it goes into the nucleus, it will bind to the DNA. Okay, so translocation of STAT to cells DNA, and when they binds to the DNA, it start to have a specific gene transcription. So in this stage, we call it transcription of specific target genes. Okay, cytokines bind to the receptors, and then this activate JAK kinase cause phosphorylation of tyrosine, and then when the tyrosine phosphorylated, so we have STAT1 and STAT2, which has the phosphorylated tyrosine will bind, or known as dimerize, they dimerize and then pass through the nucleus membrane. After they pass through the nucleus membrane, translocate to the cell DNA, and they will have a specific gene transcription. So this how the cytokine and the receptors play a role to induce in the gene transcription. All right. Shikin Zawawi. So far so good. Can you understand? I know if you cannot memorize, it's okay. As long as you can understand. Can you understand or not?
Yep. I can understand.
Can, okay, excellent. Okay, just to test whether you really understand or not only you lah, but also the rest of the members, it is better if you can, after you listen to my lecture, immediately after this, inshallah, if possible, if you have some time, we should end by 1 o'clock, if I'm not mistaken. Okay, if you have some time before Zuhur, okay, take a piece of paper and write down what do you listen from my lecture. Okay, especially on the pathways. And then bila sampai tengok gambar lah, okay, and then write down what you understand. If you stuck, then you know that you're actually having a problem, and then immediately you can text me. Okay, text me. I will try to entertain lah. Okay, inshallah. Okay, if I didn't reply to your message, just remind me, because I have many other job, because other than being a lecturer, I am also the head of grant management unit of RMC Research Management Center, handling all the grants in the university. So, but I like to share with you some of the knowledge. Hopefully, you didn't misunderstood on my lecture. That is very, very important. Anyway, let's go back to the lectures. So we have cytokines related to disease. So we have various cytokines that involves in disease. Yeah. So for example, for the bacterial septic shock, okay. So cell wall endotoxins for antigen stimulate macrophage to overproduce interleukin-1 and Tnf alpha. Okay, it also involves in lymphoid and myeloid cancers. Okay, some cancer cells also secretes what are called cytokines, like I just mentioned to you previously. Okay, interleukin-6, interleukin-8, they are the markers for cancer, oral cancer. Yeah, and that is what I call a very, very new funding. And on top of it, if you still remember what happened, what I call a report on the interleukin, cytokine storm. Okay, so that is also another thing that you can relate with. Okay, it is not in this lecture notes, but you can add. Okay, cytokine storms, for example, it is involved in the disease, okay, upon infection by COVID-19. All right, and then we have also Chagas disease, okay, in Chagas disease, okay, so Trypanosoma cruzi, okay, so it is involved in the infection and lead to the severe immune suppression, yeah, okay, so because of the depression of interleukin-2 receptor production, okay, so this occurred in Chagas disease. I'm not going to explain to you so much about Chagas disease. You can Google it later. Okay, we have less than 30 minutes, but we have here the clinical function of cytokines. Okay, as I mentioned to you earlier, it can be the marker for oral cancer, such as interleukin-8. Okay, and over here we have soluble form of interleukin-1 receptor inhibits helper T cell activation. Okay, so when you inhibit the helper T cell, you know that helper T cell can be very specific. Okay, and helper T cell is very specific towards they can detect what we call non-self cell. Okay, so those who are having graft ni macam implant lah, ataupun kita ganti kulit ke. In this case, we do transplantation, heart transplantation. How can we ensure that our body or someone else's body, when they receive the graft, when they receive the heart transplantation, the immune system will not attack the heart, okay, because this heart will considered as the antigen, the foreign body. So our immune system will automatically attack the heart. So how are we going to prevent from the immune system to attack this organ? Okay, the way is to produce or to provide interleukin-1 receptor. Okay, that is in a soluble form, which will inhibit the helper T cell, okay, from targeting the heart, the antigen, in this case, a heart transplantation. All right. So interleukin-2 conjugate with toxin will diminish rejection of kidney and heart transplantation. Okay, interleukin-1, heart transplantation, interleukin-2 with the toxin to allow kidney and heart transplantation to be success, and lymphokine activate killer cell in chemotherapy. Okay, and then we have antibody to IL-4 to reduce IgE production. Okay, and a marker for oral cancer, which I just mentioned to you. All right, I think that's all. Thank you very much for your attention. Just before we end our discussion today, I would like to open for Q&A if there is any from the student that would like to ask question. So far, I think my presentation is a bit dry. If it is in the class, it's different because of PKP. Now everyone has to. I don't know. At first, I was thinking I want to just come to the university, give lecture, but I also worried that if anything happened, then the entire class will be affected. Okay, but even I believe that they're supposed to have no problem at all. But just to as a precaution, So I decided to make it online. Just before we end our discussion, once again I would like to open for Q&A. Okay, if you want to ask in regards to cytokines, it's okay. If you want to ask something that is not involve cytokines, like cell mediated, whatever thing you want to ask, either if it is related to immunology or not related to immunology, it's also up to you. Okay, so we have few more minutes for Q&A session. Right, anyone would like to ask anything? Okay, any question?
Doctor.
Yeah.
Alright. This is about the type of cytokine. So, about lymphokines and interleukins saya faham. Tapi about chemokines tu boleh tak Doktor explain sikit?
Apa yang tak faham? Chemokine.
About the chemo attractant between cells tu. Maksudnya macam mana?
Sekejap saya cari figure yang boleh cerita. Sekiranya ada. Sekejap Okay. Boleh ke? Ada tak 3? Okay, nak explain pasal chemokine Okay, kalau kita boleh bayangkan, okay. So dalam bila perkataan chemo, apa maksud chemo? Dia yang chemistry lah, bahan kimia. Okay, chemo. Alright. Okay. So when we talk about chemokines, it is if you can search in the Wikipedia, what does it say here? Okay, chemokines. Okay, kinds from the word kinos. Kinos is movement. Okay, chemical movement. Are a family of small cytokines or signaling proteins secreted by cells. Their name is derived from their ability to induce directed chemotaxis. In nearby responsive cells, they are chemotactic cytokines. Okay, that is number one. And you can see the role of chemokines is to act as chemoattractant to guide the migration of cells. Okay, and then fine. So what does it mean there? Okay, the chemokines, okay, is a signal. Okay, it's a signal to tell the cell. Okay, where is your direction? Okay, you can imagine. Okay, kalau kita manusia, kita boleh tengok dengan mata kan? Betul? Kita ada mata. Kalau orang yang tak ada mata, dia guna tongkat. Okay, tapi kalau sel dia tak ada mata, dia tak ada mata, dia tak ada tongkat. So macam mana dia nak tahu ke arah mana dia nak pergi? Okay, so this is where the role of chemokines comes. Okay, so the chemokine will give the instruction to the cell. Okay, this is the way where you are going. This is what I call this chemokine will guide the cell to migrate. Okay, to move from one place to another. If you can imagine, you know, the cancer cell, for example, how the cancer cell from say for example from mouth eventually goes to the brain, because there is an instruction, is a chemokine that is released. Okay, that give the guidance to the cancer cell that's actually on the surface, get penetrate between the cell, okay, the epithelial cell, okay, and then what we call it as the migration of the cell, and eventually it goes into the blood vessel and then reach to the brain. So chemokines, basically it is a chemoattractant. Okay, chemoattractant or the information. Kalau kita kata signal lah, signal. Macam signal handphone tu, macam mana kita nak boleh dapat maklumat. So there is a signal. So the signal here we call it as a chemoattractant. Okay, chemoattractant when it involves in chemoattractant, okay, we call this as the chemokines. Okay, does it answer your question?
Yes. So maksudnya yang ada another term is chemotaxin tu, which been released by chemokines lah.
Boleh lah macam tu. So as long as release of chemical, okay, what we call guide the cell to move, to migrate, and that is a chemokines. Okay, chemokines is part of the cytokines, right? So just make sure you understand that. I don't want you to confuse. Ni chemokine ni masuk tak dengan cytokines? Still under cytokines. Group cytokines still under the group of cytokines. Same with interleukins is still under the groups of cytokines. Okay, all of them are cytokines, but there are 3 different categories: chemokines, lymphokines, and tadi interleukins. Okay. Any other question? Okay. If there is no question, okay, this session is recorded, and I think your class rep will share the recording later. Okay, if you have any problems to understand, okay, just don't forget to, you can ask the question later. And the lecture notes, you can have it in my I'm going to share it with you. Okay, so this is okay. So you can go to my website, hafizazmi.com. You go to lecture notes and videos. Okay, so there are lecture notes over here. you go to, I will provide the latest one. So this is my lecture, my previous lecture, Advanced Immunology. So I will put it over here. So the textbook is all this, the same textbook that I used for the reference. You just click over here and it will bring you to the textbook of interest, okay? Okay, so you don't have to worry, your textbook is already here. You just have to read whatever thing, you know, if you want to have more details on the lectures. Okay, you just have to download it. All right, fine. And then because I just mentioned to you as well, we have the list of reading materials. So all these list of reading materials that I have given in the last slide of my lecture notes are all here. Okay, so you just you can read it from here. Okay, and you can download the lecture notes also from my website. Okay, I will also upload in iTaklim. I am not a fan of iTaklim, but I will do that as well. Okay, just to ensure that everything is accessible. Okay, because some might be difficult to download from iTaklim, some might be easier to access from the website. Any of the method is okay as long as you can have the lecture notes. Okay, ada lagi mungkin 1-2 soalan terakhir. Ni Asma, everything good?
Yes, Doctor.
Okay, Mizan? Okay, Mizan? Asyik kena je Mizan ni.
Yes, okay, Doktor.
Imat, okay Imat?
Okay, Alhamdulillah.
Sekejap, isteri saya panggil benda kata.